Right now we're going to cover a really important part of our storage system design, which is how Datera places data for your applications across the physical storage infrastructure. Our storage runs on heterogeneous hardware, where each node might have different storage media, different performance characteristics, etc. And we actually abstract away that hardware and manage it for you in a way that's completely seamless and transparent to your applications, placing data automatically across the storage based on both user-configured policies as well as internal optimizations, like load balancing and that sort of thing. So this gives you as the customer a lot of flexibility in your hardware choices and in your price to performance ratio without actually adding any management overhead. Your infrastructure management becomes effortless. So here's a simplified representation of a Datera storage system with your application at the top left. You configure your application to run on Datera through the API or GUI, which in turn works with our fully distributed control plane to implement your configuration in the hardware. And that we're showing at the bottom. So in this case, we have a couple flavors of storage hardware, hybrid, and all-flash servers. Now, provisioning storage for Datera is just one single API call. It's really simple. So let's jump to our API browser on a live running system and provision a volume. So this isn't the full-fledged GUI. It's a separate interface that ships also with every running system. And it's just there to help you trigger low-level API calls and get familiar with the API. So we'll go to the volumes endpoint here, since we're creating a volume. Then the create action. There's a bunch of configuration that you can provide that I'm just going to skip over for now because we're just going to go with the basic defaults, 1 gig in size, 3 replicas. Go ahead and make the call. And there's your volume. So this is all the information that's returned from the API when you query for a volume. So you can see that it's available and deployed, and you can see the iSCSI access information that you would use to connect your application to it. So that was deceptively simple, but what actually happened under the hood to deploy that volume? So the first thing to understand is that every time storage resources are deployed, a policy engine in the control plane maps that resource to a set of policies that have been already configured in the system. Policies are a central concept in our management, and these can manage performance, data isolation, data protection, placement on hardware, economic constraints, and a whole lot of other things. But for now, we're just going to focus on one of these policies, which is the data placement policy. So when we provisioned our volume, we didn't specify a policy. So by default, we received the default placement policy configuration. So the control plane takes that policy and builds a placement map based on that policy, as well as some internal optimizations like current server loads and capacities. And then it drives that placement map down into the physical infrastructure. Now that placement map is the only metadata for active IOs in the system. So it's actually directly controlling the flow of data, even at this high level of abstraction that's policy driven. We can assume for the sake of example that we have 1 replica per storage server. That's not really how it works. It's a little bit more complicated than that, but the concept is really the same. So the control plane is going to pick 3 servers, deploy our volume, and we're ready to go. Our app can run and start running IO. Now, let's say that later on, the app has been running for a while, but the performance demands of the application increase to the point where you actually want it running on all-flash storage, for example. So this might be something you'd expect to do manually and carefully with some downtime. You have to bring the application down on one set of hardware, move it to an all-flash array, and bring it back up. We'll see how with Datera, this is actually just done in a single API call. So let's go back to the API browser and look again at the current configuration for our volume. Here's the current placement policy that's configured. Remember that right now we just have the default policy, which is hybrid, meaning place the volume on hybrid storage servers. So let's make another API call here to look at all the possible placement policies that are configured in the system. These are just the built-in ones. So you as a user can create your own in order to implement more sophisticated placement schemes with your own custom hardware, etc. But again, for now, we're just keeping it simple, and we're just going to change the policy from the default hybrid to all flash. This is really easy from the API browser, which, as you can see, auto-suggests possible values for you as you go along. So we'll just fill this all in. And there you have it. In one API call, we've now applied the all-flash policy to our volume and completely changed the performance profile of our workload as it continues to run. So again, that was really simple. So let's break that down and see what actually happened in the control plane when we made that API call and that policy change. So as soon as the control plane gets that signal from the API, it will update the placement map for the volume. But remember that we actually only have 2 flash nodes currently in our system here in our example. So actually only 2 of the replicas can move right now. And the third one is actually just going to stay where it is. We can't meet the policy's intent that the user set with the current available hardware. But we move ahead with the change on just 2 of the replicas. And once the placement map is updated, the change is again driven down into the data plane and IOs are redirected in real time. Gradually, 2 out of the 3 replicas will be migrated from the existing hybrid nodes onto all flash nodes, again, as your application continues to run uninterrupted. Now, of course, the system will raise an alert back to the user to let them know that their intended placement configuration can't actually be fully met with the current hardware, but that the application can continue to run like this indefinitely. But at some point in the future now, let's say that you're ready to actually upgrade one of your hybrid nodes to an all-flash node. So to do that, you would decommission one of your hybrid nodes, which would prompt the system to migrate all of the data off of it. Then you can power it down, remove it, and add in your new all-flash server. So what happens then is as soon as the control plane notices this new server, these new resources that have come online, it will again recompute your volume's placement map along with every other volume in the system. For the volume that we're looking at right now, it'll move that last remaining replica from hybrid onto this new server, which is all flash. Notice that you didn't actually have to do anything yourself. As soon as we're able to match the policy's intent by detecting the new resources that have come online, the control plane will do it automatically. So then the same data migration process happens. We migrate the replica onto the new server, and our app is now running on all flash. So this should give you a very real sense of how simple it is to make changes as the needs of your applications evolve over time, and how much management complexity is eliminated by Datera. The system is always dynamically responding to changes in available resources in real time, and it will always continue to try to match your intent as closely as possible with the available resources, whether new resources are coming online or going offline or failing. And again, because of the way that the placement maps directly drive the flow of I/O, the migration process itself is seamless and transparent to your application. It's done in a single pass with no special requirements like quiescing, and it has an essentially negligible impact on your application's performance as it's happening. So to broaden it out even further, the real elegance of our design is that the code path we use to migrate data around, as I've been showing you, is the same no matter what the event is that triggered the migration. So any number of internal optimizations like load balancing might cause data to move around, and that can happen very regularly. But other unexpected events such as hardware failures or user-driven changes to policies can also prompt migration. And the same goes for upgrades to new software or hardware, decommissioning of old hardware, etc. The bottom line is that the software is built on the assumption that the environment is dynamic, not static, which is obviously a lot closer to the reality. Unexpected changes are the norm, and they're all handled through this same hardened code path that might run hundreds of times a day, even under normal circumstances. So the result is a huge reduction in risk during any kind of change in resources across the entire system or any unexpected failure that could trigger data migration. And that's really a huge technical differentiator for us that's built right into the fundamental architecture of the product.
Learn more about how Datera brings the software-defined revolution to enterprise storage at datera.io and contact Datera for a free consultation.